Hello again. In today's lecture, we'll look at how to teach calculating surface area. We talked about that, of three-dimensional shapes. But we'll move on now to look at how to calculate volume of three-dimensional shapes. And we'll hinge our conversation really around, first of all, looking at a triangular prism. The triangular prism that we have is one that we looked at in the previous lecture, where we found its surface area, and this time we'll be looking at volume. Now, we should know that volume is in actual fact the amount of space a container takes up, the amount of space any three-dimensional shape takes up. So it would be the space at the bottom, which is the flat space, plus the space it occupies in the air, which would be determined by its height. So volume, therefore, is the amount of space a container takes. And we do have definitions for this in terms of the actual formula. And the best way to look at it is to look at area of the base, which would be the flat two-dimensional surface, multiplied by the perpendicular height of the object or the three-dimensional shape that we're talking about. So in our case, therefore, today we're talking about volume of a triangular prism. And in this particular prism, which I've drawn here, its volume will be found by the area of the triangular base multiplied by that perpendicular height. Area of the triangular base multiplied by that perpendicular height. Now, we know that the base is a triangle, therefore area volume would be given by area of base, which would be, in our case, the area is a triangle, so it will be half the base multiplied by the height. And this would be the area of the base that is the triangle. Now, the height of the triangular prism would be that height there, which would be, let us call it capital H. But what about this height here? This height is the height of the bay of the triangular base, which in our case would be that. It would be that. That would therefore be the base of the triangle at the base, and that would be its perpendicular height. So that would be the H. So the volume, therefore, which I should have written properly, volume would therefore be given by half the base, there is our base, multiplied by the perpendicular height, and that would be the height there. Multiplied by the height of the prism. And the height of the prism is the one that I'm indicating in H, which would be that, the capital H. But what we have to remember all the time to teach our children to think of volume not in terms of length times breadth times height, which is correct, but not all bases will be rectangular. That is important. So, if we're looking at our cuboid, the volume of the cuboid would definitely be area of the base. What is our base? The base is a rectangle. If that was L and that was B, the breadth, and that is now the height H. Area of the base would be L times B, which is that. That would be our base. So the volume here would be L times B multiplied by the perpendicular height H, which would be our capital H there, that. That is the height of the cuboid. So yes, it's therefore correct to say volume is given by length times breadth times height. But this is not constant. The best way to put it is volume is given by area of the base, that's the base. In a cuboid, it's L times B. Area of the base multiplied by the height. Why? This definition is much better because not all the bases, have length times breadth. Some bases would be, not all the bases are rectangular. Some bases will be cyclic, others will be triangular, and so on. So it is better to define volume to the children as area of the base multiplied by the perpendicular height. Good. So then let's move on to the next shape. Let us look now at a cylinder. So a cylinder then is given by, the best way to draw a cylinder really, it's a rectangle. Like that. So that's our cylinder. And we are asked to find its volume. Now, we'd realize that in actual fact, a cylinder is probably let's look at surface area. The surface area of a cylinder is given by area of two circles plus area of a rectangle. Area of a rectangle. Now, you realize that if we were to open this cylinder up, we would actually end up with a rectangle like that. The rectangle like that with two circles that way. Now, the best way again to demonstrate this with your children is let each one of them get a rectangular piece of paper, roll it up, and they will be forming cylinders. Now, that should make them realize that in actual fact, the surface area of a cylinder is rectangular. So once they open that up, they would see it is a rectangle, and when they close that up, it makes a cylinder. However, the most important point they ought to remember here is if it is a rectangle, the length, which is that, h, would be that. That would be h. But the trick part is the base. The base, in actual fact, if they were to, when they open the rectangle, they would realize that the base is the circumference of the circle. That's why the base is equal to 2 pi r, which is the length of the circumference of any given circle, the formula for circumference of a circle. Therefore, the area of this rectangular shape that has been developed from the opened cylinder would be given by the length that multiplied by the base. And this would be, in our case, would be b multiplied by h. What is our b? Is that area. Our b is 2 pi r, and our h is the height. So that becomes the area of that rectangular surface. And the area of a circle is given by the formula pi. Area is given by the formula pi r squared, where r is the radius of the circle, and even this r here is the radius of the circle. Remember this, that side was made, in actual fact it is actually this side, which is okay. This side is made by the circumference when we open it up. So area, therefore, of a circle is given by pi r squared. So that area would be pi r squared. These are identical. Therefore, that would also be, area would also be pi r squared. So let us then finalize this. So surface area of a cylinder is given by two circles. We know it's two of them, that and that. What's the area of a circle? Is given by pi r squared, and there are two of them. Plus the area of the opened rectangle, which is 2 pi r h. So that is the surface area of a cylinder. Now we have again to be very careful. That is for a cylinder that is closed on both sides. That means this circle occupies space, and that circle also occupies space. So the questions might be, this cylinder is only is closed at the bottom and open at the top. Then that would mean the circle here, the formula would only have one circle. If it is a hollow cylinder, that would mean this part here, if it's a hollow cylinder, that would mean this part, in actual fact, in terms of surface area, would wither off, would only have the rectangle. That's all it can occupy in terms of the surface area. So we have to be careful of that. Now let us look at the volume of a cylinder. We still have our cylinder. And that is the height, the capital H. That's the radius, R. So the volume of that cylinder, we have actually looked at the volume. Volume is given by area of the base multiplied by the height. So that is important. And we have also looked at the surface area, and we have found that the surface area is given by area of the rectangle multiplied by, depending on whether there are two, it is closed on both sides, so it would be the area of that circle plus area of this circle plus the area of the surface area of this, which would be 2 pi r multiplied by the height h. So that would give us the volume. Next, let us look then at a cone. Let us look at a cone. So the cone would look like that. So that would be the base of our cone. The volume of a cone, again, is the amount of space it takes up. Let me see if I can draw it better. The volume of a cone, again, would be the amount of space it takes up. So, it would be the center of our cone. Now, if we were to open a cone up, this is how a cone would look like, actually. A cone would have a circle. A cone would have a circle and a conic. That's how a cone would look like. Now, you'd realize that in actual fact, this is 1/3. If we were to have completed a circle, this would be 1/3 of that. Let us the addition to be that way. So a cone is actually 1/3 of a circle. So the volume of a cone, therefore, is given by volume is given by 1/3 area of the base but what is the base this time? We know that the base of any cone is a circle, so it's pi r squared. It's 1/3 pi r squared. 1/3, not half, sorry, 1/3. Volume is given by 1/3 of the area of the circle multiplied by the height. Now, why do we say 1/3? Because a cone actually is made up with a third of a circle, if we look at it from there. So it would be 1/3 area of a circle. What's the area of the circle? The area of the circle is given by pi r squared multiplied by h. So V is equal to 1/3 pi r squared multiplied by h. So that's how we find the volume of a cone. Volume of a cone. 1/3 area of the circle multiplied by the perpendicular height. Now the height we have to remember is that perpendicular height. That. And the r is this radius here. The r is that radius there. From the center of the circle to the circumference. That gives us the r. Now, let us look at something that is spherical then. Let's look at something that is spherical. A sphere would be somewhat like that. It's a ball, really. So the best example you can have with your children when it comes to anything that is spherical is actually to bring a ball, or ask them to bring balls that represents a sphere. Now, a sphere is said, the surface area of a sphere is in actual fact 4 area of a circle. Surface area is given by 4 multiplied by area of the cycle cross section, which is pi r squared. Okay, now what do we mean by that? You have to be a Picasso to show this. Now, we are talking about at the center of the sphere, there are 4 spherical surfaces, 4 circles that actually meet here at the center. It's very difficult for me to show that pictorially, but in actual fact, the center basically is the equator, and if we were to have drawn the equator of the sphere like that, the surface area would be the area of that. There is also one on the other side, and one on the other side, and the one. So giving us 4 spherical surfaces. And that's why surface area of a sphere, A of a sphere, is equal to 4 times pi r squared h, pi r squared h. No. What am I talking about? It's just 4 pi r squared. There's no h. There's no height here. Sorry. Now that is just 4 pi r squared. So the surface area of a sphere is given by 4 pi r squared. I've tried to show how the 4 spherical features would look like on a sphere. So that would be finding the surface area of a sphere. And I think let's try a few exercises that I would like you to try. Take this, for instance. Let's start with a triangular prism. Let's start with a triangular prism and try and find its volume. Let us say the whole of this, the length from there to there, that was 14 centimeters. Its perpendicular height was 12 centimeters. And that height with the base was, say, 7 centimeters. 1. Find the volume and surface area of the triangular prism. Find that is 14 centimeters height from there to there is 20 centimeters. Find the volume and surface area of the cylinder. It's closed on both sides. We are given a cone. We're given a cone. The radius of the cone is 21 centimeters. 21 centimeters. The perpendicular height is 40 centimeters. Find the volume. Find the volume. Okay, we are told a sphere, so that is 1. Question 2, this is question 3. Question 4, sphere has radius equal to 28 centimeters. Find its volume. A sphere has a radius of 28 centimeters. Find its volume. In all these calculations, we have to remember that pi is always equal to 22/7. It is a constant. Pi is a constant and it's equal to 22/7. So try those 4 questions then and see if you can find the volumes and the surface areas. I think that's it really. Again, when you are teaching these, always remember your children to bring their own artifacts, to bring actual cylinders, cylindrical shapes, prisms that they can find. If they're triangular, let them be triangular prisms and so on, if you want them to do that. And also cones, they should be very familiar with cones, but they can make a cone from a rectangular piece of paper and should be able to exhibit what they see, and therefore you as a teacher should be able to demonstrate the various parts, why we find the volumes and also the surface areas that they find. I think that's the end of this lecture. We'll again continue some other time. Goodbye.